Have you ever stopped to think about how you can send a photo from your phone and in seconds it just appears on your friend's phone halfway across the world? It feels like straight up magic, right? Well, it's not. Behind the scenes, there's a 7-layer blueprint that lets all these different gadgets talk to each other. And today, we're going to pull back the curtain on that blueprint, the OSI model. So let's just start with that big question. How can an iPhone in America send a photo to a totally different device, an Android phone, all the way over in Japan? They're made by different companies, they run different software, so how do they speak the same language? Well, to get it, you've got to understand that it wasn't always this easy. We have to go back in time a bit. Because in the early days of networking, it just couldn't happen. It was total chaos, a real Wild West, where a computer from one brand was basically a lonely island. All these devices were built on their own private, proprietary systems. That meant they could only talk to their own kind. A global network like the one we have today? Absolutely impossible. So to bring some order to that chaos, the International Organization for Standardization, the ISO, came up with a solution back in 1984. They called it the Open Systems Interconnection Model, or just OSI for short. You can think of it as the ultimate how to talk to strangers guide for computers. It's not a physical thing. It's a conceptual model, a reference guide that laid out the rules of the road for everyone to follow. Now, this OSI model has 7 different layers. And yeah, trying to memorize 7 abstract layers sounds kind of boring. So network engineers came up with a classic mnemonic to remember them, going from the bottom layer up to the top. Just remember this sentence: please do not throw sausage pizza away. It's a little silly, but believe me, it works every single time.
So if we look at them from top to bottom, from the stuff you actually interact with all the way down to the physical wires, we have Layer 7, Application, Layer 6, Presentation, Layer 5, Session, Layer 4, Transport, Layer 3, Network, Layer 2, Data Link, and finally, at the very bottom, Layer 1, Physical. Okay, let's break down what each of these actually does, starting at the top.
The top 3 layers, so that's application, presentation, and session, are usually called the upper layers. For the most part, these are all about software, and they deal with the functions that are closest to you, the user. This is kind of the fancy stuff that your apps talk to directly.
Okay, Layer 7, the application layer. Now here's a really common mistake. A lot of people think this layer is your web browser or your email client itself, but it's not. It's actually the protocol those applications use to talk to the network. Think of things like HTTP for web browsing or FTP for file transfers. It's the essential bridge between what you're doing on your screen and the rest of the network.
All right, down to Layer 6, the presentation layer. You can think of this layer as the network's universal translator. Its whole job is to take the data from the application and make sure it's in a format that the computer on the other end can actually understand. This is where things like JPEG for images or MP3 for audio get handled. It's the reason your computer doesn't try to play a text file like a movie. Super important, it also handles stuff like encryption and compression, which keeps our data safe and efficient. And the last of these upper layers is Layer 5, the session layer. This is the conversation manager. Its job is to open up a communication channel, keep it open for the whole conversation, and then, you guessed it, close it down when everything's done. It also directs the flow of traffic, deciding if we're in full duplex, where both devices can talk at the same time, or half duplex, which is more like a walkie-talkie where you have to take turns. Okay, we've covered the fancy software stuff. Let's move down to the lower layers, layers 4 through 1. This is where the real heavy lifting happens. These layers are all about the end-to-end transport of your data, and they use a mix of software and hardware to actually get the job done. Layer 4 is the transport layer, and it's basically the quality control expert. Its main job is to make sure your data gets where it's going reliably. The most famous protocol here is TCP, the Transmission Control Protocol. TCP is, well, it's the polite one. It breaks your data into smaller chunks called segments, numbers them, and then waits for an A-OK from the other end before sending more. If a piece gets lost, it just sends it again. This is what guarantees your photo arrives as a perfect picture, not a scrambled mess. Next up, layer 3, the network layer. Think of this as your data's personal GPS. This is where logical addressing happens. Yep, the IP addresses you've heard about, they live right here. And this is the domain of routers. Routers are layer 3 devices, and their entire purpose in life is to look at the destination IP address and figure out the absolute best path for your data to take across the giant, complicated web of the internet.
Right below that, we have layer 2, the data link layer. So if the network layer is the global GPS for long-distance travel, this layer is your local mail carrier who knows your exact street address. It's only concerned with getting data from one device to another on the same local network. To do that, it uses physical hardware addresses, called MAC addresses, which are baked into every network card. Network switches are the kings of layer 2.
And finally, we've hit rock bottom. Layer 1, the physical layer. This is where it all gets real. This layer is the actual hardware. The Ethernet cables, the fiber optic lines, the Wi-Fi antennas. Its job is to take all that neatly organized data and just turn it into raw bits, ones and zeros, and blast them out as electrical signals, pulses of light, or radio waves. So how does your data actually move down through all these layers? Well, it's a process called encapsulation. The best way to think about it is like you're packing a suitcase. As your data moves down the stack, each layer adds its own little wrapper, its own header with instructions, getting it ready for the next part of the trip.
Let's watch it happen in real time. Your data starts its journey. At the transport layer, it gets a header and becomes a segment. Then, the network layer slaps on an IP header and now it's a packet. At the data link layer, it gets another header with MAC address info and now it's a frame. Finally, the physical layer turns that whole frame into raw bits and sends it on its way. So what happens when the data gets to where it's going? Well, the receiving device just does the exact opposite in a process called decapsulation. It's like unpacking the suitcase. It strips off each header one layer at a time, reading the instructions as it goes up the stack until all that's left is the original, pure data from your application. Pretty neat, huh? Okay, so we have this perfect, elegant, 7-layer model. It explains everything. It's the foundation of modern networking, taught in every single computer science class. It's beautiful. But here comes the plot twist. We don't actually use the 7-layer OSI model in the real world. The internet we use every day, it's actually built on a simpler, more practical model called the DoD model, which you probably know as the TCP/IP model. The DoD model basically just streamlines things. It takes the 7 OSI layers and squishes them into 4. It looked at the top 3 layers, application, presentation, and session, and said, you know what, these are all kind of one big application party. Let's just group them together. And it did the same thing at the bottom, combining the data link and physical layers into one network access layer. Which, of course, leads to the most obvious question in the world. If we don't even use the 7-layer model in practice, why on earth did we just spend all this time learning about it? And here's the real takeaway. We learned it because the OSI model gives us the language. It provides the universal framework to understand, discuss, and troubleshoot networks. It lets professionals pinpoint problems with incredible precision. I mean, it's a lot cooler and a lot more helpful to say, hey, that's a layer 3 issue than it is to just say, the internet thingy is broken. At the end of the day, the OSI model is still the most important tool we have for just visualizing how data gets from an idea in your head to a signal flying through the air. So the next time your Wi-Fi dies, you can mentally walk down those 7 layers and just remember our little phrase, please do not throw sausage pizza away. The OSI model is absolutely foundational, but really it's just the start. We touched on layer 3 and those all-important IP addresses, but how did they actually work? How does every single device get a unique spot on the internet? If you want a deep dive on that whole system, let us know in the comments.